Hey, it's Robert. So this is the third video. We're going to work problem 70. Alright, let me read it. So Mars has a radius of 0.53 Earth radius and a mass of only 0.11 Earth mass. Estimate the acceleration due to gravity on Mars. Alright, so here we're not asking for a force, they're asking for an acceleration due to gravity. When you hear something like acceleration or acceleration due to gravity, your mind should go to this equation. Alright? So remember, with a force, we're going to use the other equation that we've used in the previous problems. But with acceleration due to gravity or acceleration of gravity, we're going to use this guy. So, let's go ahead and work this out. So it tells that we need to figure out what these are. So we already know what g is. It's a constant. So 6.67 times 10 to the negative 11th. M is going to be the mass. So we know that it's 0.11 times the mass of Earth. And again, the mass of Earth is given on page 84, I believe. Let me check. Yep, bottom of page 84 gives you Earth's mass, which is 5.98 times 10 to the 24th. So when you take that and you multiply it by 0.11, you end up with 0.6578 times 10 to the 24th kilograms. Now we need the radius between them, and we know that that's 0.53 times the radius of Earth. The radius of Earth is given on page 85, so you get 0.53 times 6,000, and again I put this in meters instead of kilometers, and so you end up getting 3,376 100 meters. Alright, so it told me 0.11 times Earth's mass, so I just took Earth's mass times 0.11 to get the mass of Mars, and it told me the radius, the distance between the Sun and Mars was 0.53 times the distance to Earth, and we know the distance of Earth is this, so take that times 0.53 to get the distance to Mars. So we have mass of Mars, distance to Mars, universal gravitational constant. So we have everything to plug in here, and now we just plug it in. So little g, don't get confused between little g and big G. Little g is the acceleration due to gravity. Big G is just a constant. Okay? Big G never changes. Little g changes depending on where you are. So let's plug this in. So I plugged in for G. Now plug in for M using this guy. And then plug in for R using this guy. Alright, now just like we did in the previous problem, and go back and watch that video if you haven't seen it, we can rearrange these terms, right? So let's go ahead and pull out the easy numbers to work with. It doesn't care what order we multiply things in. Right? And if you end up squaring this number down here in the denominator, you end up with 1.1398 times 10 to the 13th. Alright? So now let's go ahead and multiply these two terms here. 6.67 times 0.6578, and that will give us 4.3875. And then remember that when we multiply exponents, we add the exponents there. Go ahead and watch the previous video if you don't know how to do that. So you get times 10 to the 13th. Okay? And so these two 10 to the 13ths cancel each other, So you're left with 4.3875 divided by 1.1398. And when you do that, you get 3.849 meters per second squared. And there you go. So that is how you work problem 70. Now let's go ahead and do problem 74. Well, actually, I'm kind of running out of time. I'll do 74 on a separate video as well. So go to the next one if you have questions on that. Thanks.